Number 18 is a little bit similar to number 16 in the sense that we have a radical in the denominator that we want to get rid of. Now, some of you might be looking at that and going, there's no square root there, so what are you talking about? Remember that I represents the square root of -1, so we actually do have a radical. So if you think back, this is one where you want to multiply by the conjugate of what's in the denominator to get rid of that I, or square root in this case. Okay, so we're going to FOIL on the top and FOIL on the bottom, and then we're done. Okay, so on the top, if we FOIL, we get 1 times 5 is 5. So that's the first. The outer 1 times -2i is -2i. The inner, we've got positive 10i, and then the last, we have -4i squared. On the bottom, same thing. First are, let's see, we've got 25, and then we have minus 10i plus 10i minus 4i squared. So we follow the same pattern that we did on the top. Okay, now remember that I squared represents -1. Okay, so what we can do is we can change these terms to be -4 times -1, because again I squared is -1 on both the top and the bottom. All right. So then we want to go through and combine like terms. So we have -2i plus 10i on the top. That is 8i, so we have 5 plus 8i on the top. On the bottom, we have -10i and positive 10i. Those cancel each other out. Then we have 25, -4 and -1. That turns into a positive 4. And 25 plus 4, that is 29. And then you want to go through and see if you can simplify. In this one, not much else we can do. So we are done. Okay, number 19. Everybody looks at number 19 and is confused. And when you guys see how simple this solution is, I hope that it will stick with you. Okay, square roots. So here's what we're doing in this problem. Square both sides, okay? And then we have just a basic Algebra 1 problem to solve. Because what happens to squared and square root? They cancel each other out. So cancel out, cancel out. B divided by 2 equals 2b minus 12. Okay, and then to get rid of this 2 on the bottom, we multiply both sides by 2. Okay, so this one we have to multiply everything by 2, so make sure you're paying attention to that. So b equals, if we distribute 4b minus 24, and then, again, basic Algebra 1 level problem, so we all should have a very good understanding of how to solve this, just doing the opposite of what's being done until you have isolated the variable. So we have b equals 8. See? Not so bad. All right, let's see, number 20 we can do over here. Number 20, I'm going to go through just the mechanics of how to solve it, but if you would like to see where this comes from, again, please come see me in class. We went through it when we first learned it, but it was a while ago, so I get it. You guys are all done. We're all done. It's the end of the year, right? So we're all ready for summer vacation. Okay, so here we are. So that famous Pythagorean theorem, that's what we are using in this problem. A squared plus b squared equals c squared, and c is what we're solving for. We are solving for the hypotenuse of a right triangle. And again, some of you might look at that and go, where's the right triangle? Come see me if you still would like that more enrichment explanation. Okay, so c squared. So we get 100 plus 25 equals c squared. 125 equals c squared. Opposite of squaring is square root. Take the square root of both sides. And then we want to do the same thing we did a couple of problems ago. We want to simplify this radical. You always want to simplify or reduce as much as you possibly can. So I showed you the other way with the looking for perfect squares thing. Let's do the factor tree on this one. So 125 is 5 times 25. 25 is 5 times 5. Because we have a square root, we look for pairs of numbers, and anything that's left over stays underneath the radical. Okay, so within each pair, let's write our radical down here. Okay, you guys can still see that. Within each pair, 1 gets crossed out and 1 comes outside, and again, anything that does not have a pair stays underneath. So c, or the absolute value of that complex number, is 5, radical 5. Okay. Moving right along, number 21, we all better get right on the test. This is one that literally should take you about 5 seconds because you have to look at all the options. If you didn't have options to look at, it should take you about 2. Okay, so we have a graph here. Sure, I'm keeping track of time. We have real and we have imaginary. 1, 2, 3, 4, 5, and 1, 2. And we have a point up there. And it says identify the complex number graphed. Well, what we have here is we've gone to the left 2 in the real direction, and we have gone up 5 in the imaginary direction. So that number is -2 plus 5i. See? We all better get that right. Okay, let's see. I'm going to go ahead and switch over to the next video to start number 22. So I will see you there.